So in the previous video we went over Lewis structures, determining or writing the Lewis structure when you've been given an even number of valence electrons. But if we are dealing with an odd number of valence electrons, the concept of formal charge becomes very important. So formal charge is simply the difference in the number of electrons on a free atom and the number of electrons assigned to that atom in a certain molecule. Such is what we refer to as a formal charge. So take for example, if you've got NH, so NH2, how would we write the Lewis structure for this one? Now as we can see, we've got only one nitrogen, so it will be nitrogen there, and then we've got two hydrogens on the two sides. So the two hydrogens are already balanced. So for us to balance this nitrogen with the electrons, 8 electrons, how do we do it? Of course we need to put 4 electrons there. Now looking at this compound, how many valence electrons do we have? Nitrogen is in group 5, so it has got 5 valence electrons. And then we've got 2 hydrogens, each with 1 valence electron. So this is giving us 7 valence electrons. Now from what we can see, this bond has got 2, 4 in this bond, and then this is 6, this is 8. So we have used the 8 electrons, but only 7 are present. So because of that, this won't be just like a molecule like that. It is going to carry a negative. That is meaning we've gained an electron for it to be 8. So this molecule is like that with a negative. So that is because we had an odd number of electrons after calculating. It only gave us 7. So there was need for us to calculate the formal charge. So formal charge, remember we said this, the number of electrons on a free atom. Nitrogen has got 5 electrons in the outermost shell minus the number of electrons assigned to that atom in a molecule. So how many electrons are assigned to this one? Now the number of electrons, we can say formal charge is given by valence electrons minus bonding electrons plus non-bonding electrons. Okay. So in this case, how many electrons have bonded? So we have got 1 electron here, 1 electron there. So that is 2 electrons have bonded. What are those which haven't bonded? We have got 2, 4. Okay. So that is 4. In other words, the valence electrons assigned to nitrogen in this molecule, there are 6. As you can see, there are 6 electrons around the nitrogen. So that will give us a formal charge of -1. That's why this compound carries a -1 charge on top. So that's the concept of formal charge becomes very important. Now there are some compounds which exist with more than one Lewis structure, and so we apply the same concept of formal charge to determine which Lewis structure is going to be the most applicable. We can also look at H3O. So in here, the valence electron, we have got 3 hydrogens, each having 1 electron in the outermost shell, and then we've got 6 electrons in the outermost shell for oxygen, and this is giving us 9. 9 is an odd number. Okay. So when we are writing the Lewis structure for this compound, oxygen is the central atom, and then we've got hydrogen, hydrogen, and hydrogen. Now already we have got 3 bonds, meaning 6 electrons. So we need 2 more to be able to balance. Now if you count all the electrons which are here, we have got 2, we have got 4, 6, and 8. We have only used up 8 electrons to write this compound. So what is that telling us? But we have 9. So it means 1 electron has to be lost. And so H3O has a minor, a plus. So it gains a plus because 1 electron has been lost if we are writing the Lewis structure like that. If we want, we can calculate the number of lone pairs on the oxygen. Remember, lone pair is the group number minus electron shared over 2. Oxygen is in group 6. How many electrons has it shared? It has made 3 bonds, so it has shared 3 electrons. And then over 2. So that will give us 6 minus 3 is a 3. 3 over 2 is 1.5. So that is giving us one lone pair and a half. Half a pair is 1 electron. So we have got 3 electrons. It was supposed to carry 3 electrons. Now oxygen is in period 2. Period 2 can't have an expanded octet. And for that reason, instead of having this electron there to balance up the 9 which we can see, that electron has to be lost. Okay, so that is the Lewis structure in this case. So this one has got a positive charge. Okay, so we can look at another compound. So we apply the concept of formal charge. So if we are asked to write the Lewis structure for sulfur dioxide, so first let's find the valence electrons. Sulfur should be in, sulfur is in group 6, just like oxygen. It has got 6 electrons in the outermost shell. Then we've got 2 oxygens, each with 6 electrons in the outermost shell. That will be 12 plus 6, that is 18. Okay. Now this is an even number of electrons, so we don't need to worry about formal charge. Of course, we can calculate the formal charge. Okay. So now the Lewis structure for this one, we are going to have sulfur with an oxygen like that. So we have made 2 bonds. So each bond has got 4 electrons. Okay. We need to make sure that our atoms which are not the central have got a balanced octet. So this one oxygen needs 6 more electrons to be stable. Even this other one needs 6 more to be stable. So let's calculate how many electrons we've used. So these are 6 on the oxygen, 6 on the other oxygen, and then 7, 8. Okay, 6 on this oxygen, 6 on the other oxygen, that is 12. And then that 12, here it will be 14, and then 16. So we are on remaining with 2 from the 18. So those 2, they are supposed to come here. Okay. Now, the way it is like this is the sulfur balance, because sulfur can have an expanded octet. Why can it have an expanded octet? Because it is in period 3. But as you can see, it has only 2, 4, and 6 electrons. And this is not possible for sulfur. So instead of it being like that, what is going to happen is, of course, it has got one of these oxygens can bring their 2 electrons to form a bond there. So instead of having these, they go. We have a bond like that. So this is the first possible Lewis structure which we can have, where oxygen has got how many electrons? These are 2, 4, 6, 8. And then for sulfur, 2, 4, 6, and then 8. And then the other oxygen has got 8. So this is one of the possible Lewis structures, where all the atoms, and let me not even say possible, let's say this is the Lewis structure for sulfur dioxide, because everything has got 8 electrons. So we can actually calculate the formal charges for all the elements which are here. So for this oxygen, what will be the formal charge? The formal charge is the number of electrons for oxygen, just like alone, that is 6, minus the number of or electrons assigned to the oxygen in this molecule. So as we can see, we have got 6 of these electrons, and then plus 1 which is there, so those are 7. So the formal charge for in this case is -1. What of for this sulfur? The formal charge is going to be, sulfur has got 6 electrons in the outermost shell, minus how many electrons assigned to this sulfur in this compound. We've got 1 here, and then 2, 3, 4, and then 5. So that is 5. So in this case, it has got a positive 1 formal charge. And then if we go to this oxygen here, the formal charge is going to be, oxygen, you know, it is in group 6, it has got 6 electrons in the outermost shell. And then this is 2, 4, and then 5, 6. So that is 6. So 6 minus 6 will give us 0. So what you can see is, this one is negative, this one is positive. So these two are going to cancel out. So 0 plus this 0 which we already have here. So the overall charge for a sulfur dioxide molecule is 0. That is because the former charges have cancelled out. Otherwise, if the former charges didn't cancel out, it would have been a charged molecule. Alright. So that is the Lewis structure for sulfur dioxide. You can look at another compound. Let's say cyanide. So what will be the Lewis structure here? So let's first find out the number of electrons. So electrons for carbon, there are 4 electrons in the outermost shell. Nitrogen is in group 5, so there are 5 electrons in the outermost shell, giving us 9. Now 9 is an odd number of electrons. Okay. So for this one, actually it can have many possible Lewis structures. So we have carbon and nitrogen, like that. So if this one has a single bond here, then how many electrons are going to surround these others for them to be balanced? It will be very difficult because we've used 2 electrons here from the 9, and we are remaining with how many? We are remaining with 7. So those 7 will be very difficult to put around these 2. So what you do is, we know that carbon can form 4 bonds. That is because it can lose all the 4 electrons or gain all the 4 electrons. Nitrogen can form 3 bonds. That is because it gains 3 more electrons. So what you do is, that one is going to gain 3 bonds. So these 3 bonds have got 6 electrons. So now what those 6 electrons we have is, we have 6 electrons, and then the charge here is 9. I mean the electrons which are available are 9, so we are remaining with 3. So this nitrogen has got, each bond, remember, has got 2 electrons. So those bonds carry 6 electrons. So to balance the nitrogen, we need to put 2 more. To balance this carbon, we need to put 2 more. Now we had only remained with 3, but we have put 4 electrons. So that means this needs to gain an electron. That gaining an electron, that's why we see a cyanide is going to have a negative charge there. Okay. So that will be the Lewis structure. It's going to gain 1 electron for it to have a balanced octet, like that. So the other one which we can look at is, let's say, OCN minus, this compound like this. So let's determine how many electrons are present. Electrons, oxygen has got 6 electrons in the outermost shell. Carbon, there are 4. Nitrogen, there are 5, but that negative means we're adding 1. So that is 10 plus 6, which is 16 electrons. So what is going to happen here is, now we need to determine which electron is going to be the central atom. Now the central atom is always the atom. I said which electron is going to be the central. It is which atom is supposed to be the central. So the one with lowest electronegativity is going to be the central atom. So in this case, our carbon is the lowest electronegativity atom. So it's going to be the central. You can have nitrogen there and nitrogen there. I mean, and oxygen, not nitrogen. Now, how are these electrons going to be distributed? So, of course, we can have this bond, but are we going to have a stable structure? If this oxygen gains, because if this is a single bond, it means oxygen lacks 6 more electrons to have a balanced octet. This one also lacks 6 more to have a balanced octet. Carbon lacks then 4. How many electrons have we used? So these are 6 on the oxygen, plus here 8, 10, 12, 14, 16, 18, 20. We've seen that we have even gone beyond. So this can't be the Lewis structure for this compound. But we know that, of course, oxygen can form a double bond. Oxygen can form 2 bonds. We know carbon can form a maximum of 4 bonds. Nitrogen, we know, can form a maximum of 3 bonds. So what is going to happen is, this is what we have. Oxygen can form a double bond like that. So it means if it forms a double bond, it needs only 4 electrons to have a balanced octet. And then this carbon has already 2 electrons, 4 electrons, 6, so it only needs 2 more, 2 there. But this one needs 6 more to have a balanced octet. So if we can count, this is 2, 4, 6, 8, 10, 12, 14, 16, and also 18 there. So we see this isn't balancing. Okay, this isn't balancing. Even if we were to calculate the formal charges, of course this is it is one of the possible Lewis structures which we have. And at the same time, we can have a double bond here, and then here we can also have a double bond. So what that means, here we can have 2 electrons like that, and then even here we need to have 2 electrons. Now the way I've put them, okay, let's just put that. For the carbon, it has got already 4 bonds. 1, 2, 3, 4. And each bond carries 2 electrons, so it is already stable like that. And then we can have another Lewis structure. We know nitrogen can form even 3 bonds. Carbon can form 4, so there can be 3 bonds here. So this one is going to have 2 more electrons like that. Carbon in this case, as we can see, is going to have more than the required number of electrons. So instead of having this bond here, that bond, the electrons, were going to take them there. So we're going to remove 1 bond. So that will just be 1 bond, and then the 2 electrons go there. So now carbon has got 8 electrons. Now this nitrogen needs 2 more electrons like that. So everything has now balanced up. Okay. Again, at the same time, this one can't be a possible Lewis structure unless if we had put a double bond there so as to balance the number of electrons. So as we can see, we have got 4 plus 4, that is 8 electrons for the oxygen. And then we need to remove this lone pair which is here. So what we have is carbon has got also 4 things, and then even nitrogen is supposed to have 4 things. So this one which is here will go. Okay. So it has got 2, 4, 6, 8. So everything has got 8 electrons. So these are the possible Lewis structures for this compound. Now which one is the most stable Lewis structure? Because as we can see, the electrons have balanced. The octet has been fulfilled in all these compounds. Now which one is the most stable? So the most stable, we calculate formal charges. So we need to calculate the formal charges for nitrogen and also for oxygen. Why not for carbon? Because for carbon, the formal charges for in all the compounds, it will be the same. Let's try to confirm. So formal charge for carbon is going to be equal to, okay, so the formal charge in this case, formal charge is supposed to put Fc. Now to mean for carbon, let me put a small c there. Carbon has got 4 electrons in the outermost shell. But in this compound, carbon is assigned how many electrons? So there are still 1, 2, 3, 4. So there are still 4. So that the formal charge is 0. So in all these compounds, carbon has got a formal charge of 0. But if we come to oxygen in this compound, formal charge for oxygen, oxygen has got 6 electrons in the outermost shell, minus in this compound, how many electrons has been assigned to oxygen? There are 2 there, 4 there, 5, and then 6. So that will be 6 minus 6, which is 0. What of for nitrogen? What's the formal charge? Formal charge for nitrogen is going to be, nitrogen in this of course we know nitrogen has got 5 electrons in the outermost shell, minus in this compound it has got 1 there, 2 there, 3, 4 there, 5 in this bond, 6 in that bond. Okay. So that is giving us -1. If we come to this other one, the formal charge for our oxygen is going to be 6 valence electrons minus the electrons assigned to this compound is also 6. So that will be 0. And then formal charge for nitrogen in this compound, we know nitrogen has got 5 electrons in the outermost shell minus. In this compound, what's the formal, the valence electrons? We have got 4, 2, 4, 6, 8 there. Note, so this is 2, this is 4. This one bond, one nitrogen has got 1 electron there. Then with this one, there's also one nitrogen, one electron from nitrogen. So those are 6 in total. So that is giving us still a -1. Okay. And then if we come to this compound which is here, the formal charge for oxygen is equal to valence electron which are 6 minus. In this compound, how many electrons have been assigned? There are 4 there. These two are making 4, 6, and then 7. So that is 7, giving us -1. And then the formal charge for nitrogen in this compound, nitrogen is 5 minus. We have got 2 there. And then these 3 bonds each has 1 electron from nitrogen. So that is 5. So that is giving us 0. Now, which of these compounds has got a stable formal charge? Which one is going to be the most stable compound, in other words? So considering just the second one, there's something that we should have checked out. Okay. No, on the first one, this compound, the formal charge for the oxygen and also for the nitrogen, I think I have swapped them. Let me just redraw that one. We know that there's a double bond. It's just that I drew the same compound with this one which is here. So that's why the formal charges were all the same. So the other possible structure which we can have 3 bonds on the oxygen like this, and then only 1 bond on the nitrogen. So the carbon has got balanced bonds. And then here oxygen, since it has got already these 3, which also 3 bonds carrying 6 electrons, so it needs only 2. And then the nitrogen therefore is going to have 6 because it has only 1 bond. So it has a balanced octet. Okay. Now the formal charge now for oxygen is going to be 6 minus. In this compound it has been assigned 5. That is because in each of these 3 bonds there is 1 electron for the oxygen, plus those 2 on the lone pair. That's making 5. So that is giving 6 minus 5, which is a +1. Then the formal charge on the nitrogen supposed to be, okay, nitrogen is in 5, okay, and then we are removing. Now in this compound, what's the formal charge assigned to nitrogen? So in this compound, the formal charge assigned to our nitrogen is, the valence electrons assigned to our nitrogen, they are 6 plus that one which is 7. So that is giving -2. Okay, like that. Now what we need to know is, in an atom, in a compound, electrons always want to have a formal charge as close to 0 as possible. So we go for those which have formal charges much close to 0 as possible. So at least -1, 0, 0, -1. Now this one is +1 and -2. So this one goes out. The formal charge is is too much away from 0. Again, what you need to know is the negative charge always wants to result on the most electronegative atom. So here we've got oxygen, which has remained a nitrogen. Now between oxygen and nitrogen, which one do we think should have the negative one? Because in here it is nitrogen with a negative 1 and then oxygen as a 0. In here oxygen as a 0, oxygen as a negative 1, nitrogen as a 0. So which one is true? So which one is the most electronegative? Electronegativity on the periodic table increases as you go towards fluorine, and oxygen is much closer to fluorine, so the negative should reside on the oxygen. Therefore, the compound where the formal charge is on the oxygen is here. So therefore, the correct Lewis structure for our compound in this case is the third one. So the correct Lewis structure for OCN minus is O, making a triple bond with nitrogen like that, then having those bonds. So that will be our correct Lewis structure, the most stable Lewis structure. So thank you so much for having watched this video. Have a blessed day.